Hey everybody, this is Larry. This is day 21st of the April Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's poem. We have 2145, count the hidden sequences. Okay. Today I ran a couple of miles just to kind of keep my foot loose, get my feet loose, my run loose. That's basically my training. I am probably going to take it easy this week as I go on vacation the week after that. And just want to keep my legs and my body fresh, really, because when I go traveling, I tend to travel like I walk like 10, 15, 20 miles a day for the entire duration. So yeah, just to see everything, of course. So we'll see how that goes. But today we have 2145 kind of hidden sequences. Let's see what hidden there are. What are the hidden secrets? Yeah. Okay, so you have an array of integer differences describe the differences between each pairs of consecutive different. Okay, so for example, so you're given differences, you have 1, -3, and 4, you have lower 4, then now you, okay. I kind of remember this from a contest, even though this feels more recent than it is, but yeah. I mean, I think the idea is actually not super bad. What's lower is lower, let me double check real quick. I'm going to bring up the drawing things. So hang on. Let me read this. Okay, so I just want to double check it's not the beginning and the end, and it's every element, because there's just a couple of variations. Maybe I'm thinking of a variation anyway. But in any case, yeah. So what does this mean? I think the way that I always preach problems in general is try to figure out a way to visualize this, right? And this visualization idea for different problems is a muscle that you have to use a lot to kind of be able to do in your head. Sometimes I'm able to, and sometimes I'm still not. That's why I always have a notebook and pencil and just draw it out. For you at home, of course, I'm just drawing it on here. But normally, like I said, pencil and paper, just to kind of, also I'm getting old. I think like my brain is a little bit, not seeing things for visualization purposes as much as I would like. But in any case, so you have differences, right? So what is the differences? Let's take a look at example 1. We have 1, -3, and 4, right? So then the idea that I would think about for visualization is just, just draw XY axis thing. Let's just say you start the first point at 0, right? So here x is equal to 0, and then you have the +1, so then you draw a line. I mean, pretend this is roughly right, and then -3, maybe that's a lot quite, and then +4, right? So what's that? So like something like this, right? I mean, it's not quite. I mean, it's close enough, hopefully, right? And then the idea here is that then now you have 2 bounds, a lower bound and an upper bound, right? So you have like some upper bound. In this case, is a 6, and then a lower bound, right? In this case, actually, in this case, is a 1. And of course, I did start drawing out from this 0 delta just to kind of get the shape of things. But for this problem, you are supposed to kind of basically take this black line and then shift it up or down so that every number fits into this range, right? And of course, like I said, I didn't draw this quite to scale, but you get the idea, right? So then now we'll draw it up and down. And then now for me, right? I guess that's kind of, like if I wanted the actual path, I mean, the path matters, but after you draw it out, you realize, well, what are we actually constrained by, right? What are our limiting factors? What are the things that prevent us from moving up and down? Well, for me, it's just going to be the high point and the low point, right? So here, because anything in between the high point and the low point, well, that's going to be in between. So as long as the high point is underneath the highest and the low point is underneath the lowest, then we should be good. So yeah, I think that's basically the idea. And then basically, and then the next idea coming up from this visualization, if we were to draw it out, is that, okay, so let's say we are able to move this up. I'm going to shift this a little bit, to the right here, right? And then now we have something like this, right? I don't know. Like I said, this is roughly to scale, but not quite. So we have something like this where we just kind of match this high point to say the high. And without loss of generality, you could do the same with low, but then now, well, how many degrees of freedom do we have? How many choices do we have to kind of move down, right? Because here we're at basically the most top, and maybe we could have done the other way. I don't know. Actually, also, I kind of drew this wrong. This kind of just goes here, but okay, whatever, right? I mean, it's just for visualization, right? And then now, of course, the low point in this case, actually, it would be here. Then now we just figure out, well, this delta is the number of things we can move, right? Because if we move past that, then the low point will move past the low point, and we can't move anymore, right? And that is how I would kind of think about this problem in terms of visualization. Yeah, and keeping in mind, of course, I'm solving this live, so yeah. So if I make any mistakes, my apologies. That's basically what I would think about this problem out of my head, right? Yeah, and then so now we can maybe say, yeah, let's just say current is 0, 0, right? So for D in differences, we want to say current, we add it by the delta, right? And then as we said, we want to keep track of the highs and the lows. So maybe high, up, there was an upper and lower, so it's a little bit confusing to name things, but maybe that's fine, right? So high is equal to 0. Yeah, high is equal to 0, low is equal to 0, right? And yeah, and this is of course relative to the current, so so we don't have to kind of keep track of, right? So then now what we're writing now is we just keep track of high and low, right? So high we update max, and then low we also update low, right? And then now you could, like I said, you could do it either way, putting high to the max or low to the lower. So for now I'm going to say move high to the upper, and the way that we move high to the upper is just by calculating the difference, right? If upper minus high is going to be the delta, and then that's basically now you shift it to that distance, right? So if your high, for example, if your high is 4, your upper is 6, then now you're shifting up by 2, so then your starting point is going to be 2, right? Yeah, and then now from this, yeah, from this now we have to reindex what low means, right? So low, we want to add this, right? We want to add this, so that now low is the maybe I could use more variables, I don't know. But now yeah, now we're shifting low, right? So okay, maybe let me just write it. So this is the shift. So then now, but then we have to shift all the other coordinates. In theory, you can move all the points, but like I said, for this problem, you only care about 2 points, the high and low. So that here we shift low, right? And now that we shift low, then now we have to try to find out how much gap do we have, right? So it's going to be low minus lower, and that should be the answer. Maybe +1, because not shift, because if you have, I think it's +1, because if you well, for example, if low is equal to lower, then you still have one way, right? Because you just don't move. And if you have 2, then, or sorry, if the delta is 1, then now you have 2 choices, right? Between the 0 and the 1. So it's going to be this +1. And of course, this could be negative if it's not possible. So we want to say there's going to be this. Is it min or max? I don't know. Right, I think this should be good. Maybe it's off by 1 though. Am I silly? I am, because I think I'm writing in other languages sometimes. But yeah, looks okay for these. Am I confident? I didn't really look at examples. I mean, this one we did. This one seems reasonable. It has negative numbers, right? So we could play around with it. And this one has 0, so that's also good. But yeah, let's give it a quick submit. Hopefully we're good. And there you go. Yeah. So like I said, don't be afraid to draw it out. I think once you draw it out, it's not super bad. How long did I take on this one? Like a couple minutes. And a lot of reverse drawing. So yeah. What's the complexity here? This is going to be linear time, right? and constant space, and that's it. Yeah. I mean, I'm doing it now on 420 and Easter and all these things. So hopefully, yeah, happy Easter, happy Passover, all the good holidays, and have a great week, everybody. Anyway, yeah, thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.